Welcome to a super sunny summer's day at Sportmotive. We're going to do a special today on our Evolution chassis cars. We're going to show you just what we've got in at the moment, quick walk around the workshop, and we seem to have one of every colour in at the minute. Let's go inside. Okay, so we're going to mainly focus on this car and what's underneath it in this episode. But I'm going to quickly show you around the workshop, just showing you what day-to-day projects and work we've got on. The Serb we showed you before has had quite a substantial amount of work, and we've finished all that now, and now it's given us electrical issues, as they often do, so that's why that's still here. This Tuscan, Tony's Tuscan, looked after this for a few years now, not that long, but he's had it for a very long time, and it's finally due in for an engine rebuild. It's done 74,000 miles, so it's done well. It's done better than my Tuscan did anyway. So Griffith in for full suspension rebuild, and Chimaera in for full suspension rebuild. And we're now fitting the first sets of Motorclan wishbones that we've made. So we've basically done a full four corners restoration on this car. It really wants a body off chassis restoration, but it's not quite there yet, but the wishbones were pretty shot and all the bushes were pretty shot. So what we've done is we've done a complete corner off, so that when the customer can do the full body off chassis restoration, those full corners can just be pulled off and put back on again. And as I say, this has had I think this is the second set of Motorclan wishbones now that we're fitting. So it's had all four corners off, everything blasted and powder coated, new wheel bearings, brakes as necessary. Okay, a local customer, Wayne, has just recently bought this Griff. Nice looking car. It's got a few running issues with it. It's giving us a bit of a head scratch at the minute. We're just working our way through that. We've got a gaggle of Griffs in today, an abundance of Griffs. Another Griffith, a new customer, again recently bought. It's not had a lot of work in a long time, so we're just about to assess this really and give a report back before we delve in too deeply. This Griff has just come down from the body shop. We've just done a rear accident repair on this, so we'll show you some pictures of that in progress. And customers just asked us to service it while we've got it. Another Griffith in for camshaft, common problem. So this is the main reason we're here today. This is the main focus of today. So we've took the body off Project Rocket now, Nick Simpson's car, and we're going to talk quite a bit. I'm going to waffle on quite a bit about our Evolution chassis and what led us to it and what we've done. Okay, so this is our Griffith Chimaera Evolution chassis, as we call it, because it's evolved from a TVR chassis and it's evolved from what TVR did on the later cars. We showed you one in bare metal in one of our older videos, and we just wanted to take the opportunity while we got this one body off, we can show you one complete built, and also quite opportune that we're also restoring the standard chassis at the minute. So side by side we can show you all the differences then. It's also opportune, well planned, that we've got this car here today, so we're going to show you that later in the video too. So the initial development of the chassis was driven by customers wanting to put bigger wheels on, wanting to fit the spider wheels. And the suspension geometry, the steering geometry on the standard Griff and Chimaera is quite compromised. And putting bigger wheels on actually sort of accentuated the poor steering geometry. So our first port of call was to redesign the front upright, and we initially looked at using the later TVR Tuscan upright. This is TVR's original front upright from a Griffith Chimaera, which is actually from a Ford Sierra. So a bit of a parts bin compromised part really. And the problem with this is, this was obviously originally designed for a McPherson strut. So its top ball joint would have been up here, bottom ball joint there. TVR reduced that ball joint position right down, and then by doing that, increased the steering axis inclination. So it's running sort of 14 degrees of steering axis inclination, which gives quite strange steering characteristics. And also, customers were wanting to fit the spider wheels, and these are 4 studs, so we had to develop a 5 stud conversion with this flange, which isn't quite big enough. So all these things were leading us on to try and improve the car. And as I say, the first protocol was to develop a front upright. At the time, we were also installing LS conversions, or we were just starting to do. So it led on to developing further parts of the chassis because we needed to make it stronger, more rigid, because we were putting lots more power in. So we basically went back to drawing board. So from a structural point of view and a rigidity point of view, we looked at the materials that TVR had used and the way they built the chassis. And the original chassis is all ERW tube, it's all seamed tube, and 60x40 box section, lower box. We looked around at what materials we obviously wanted to use CDS tube in the tube areas, and we discovered a better box section. So it's actually a thicker wall, 2.5mm wall compared with a 2mm wall of the original chassis. Obviously a thicker wall, it's a stronger box. It's actually marketed as Strong Box, that's the trade name of it. So after we considered materials, we looked around at where we could add rigidity and looked at body limitations of the body shell itself. And we added quite a lot of structural tubing in the engine bay and transmission tunnel area, because we realised that in the standard chassis you've got quite a big open area where the engine sits, and we were seeing standard chassis fatiguing the main box section here, which we felt was due to the weight and the torque of the engine sitting in that one place, and you've effectively got two chassis legs that aren't well enough tied together and can move around. So we put lots of extra tubing around transmission tunnel area feeding into the engine bay, so those there. And then down each side we managed to get an extra 3 intermediate tubes down each side. TVR chassis got quite a few big gaps, and also they put tubes that aren't opposing each other. So again, from a rigidity point of view, we felt transmission of forces through the chassis, you want tubes that are opposing each other and working against each other. Gearbox cross member, we also made a much more structural cross member rather than the gearbox just sitting in some mounts. We made a cross member that actually ties the two main box sections together. So once we considered lots of structural and rigidity improvements, we then started to look at installing the LS engine and gearbox and differential, where we would improve and make our life easier installing the engine. The first few engines that we installed, we had to make exhaust manifolds going forward like TVR did, which just puts inherent problems into the engine bay, heat into the engine bay. It's difficult to package the front of the engine then with your ancillaries. So we wanted to widen the chassis so that we could get exhaust manifolds going down the sides and out of the engine bay. And we looked at the body shell, and we found that by just widening the footwells slightly, or trimming an inch out of each side of the footwells, we could widen the chassis by 100mm. So this is the only real area that we have to modify the body. We cut a 25mm section out of this body section here, and then close this gap. And this has no effect on the footwell of the car whatsoever, because it's about 100mm away from the furthest point of travel of the pedal box. We then looked at how the engine was mounted, and again we've made a much stronger engine mount that rather than the engine just sitting on some mounts, it's got mounts that are encapsulated, won't go anywhere. Even if they fail, that engine's not going to go anywhere, it's not going to fall out of the chassis basically. So we also decided to make the diff cage area wider, because again we were thinking that in the future we might end up needing to put a bigger differential in, which has paid dividends, because Nick's diff is one of the first cars we've put a Ford 9-inch Mustang differential into. We need a bigger uprated diff with this engine that we were putting in. So then we moved on to analysing the suspension, the geometry. We looked at the Griffith and the Chimaera, and we looked at what TVR had developed over the years, the Sagaris and the Tuscans. And we used some suspension design software that allowed us to analyse what the car was doing in certain conditions, so degrees of turn in and roll. From that analysis, we found that the theoretical roll centre of the standard Griffith Chimaera chassis was actually below ground, which is obviously not good. And through the development, TVR had raised the roll centre through the various models, the Tuscan, the Sagaris. So what the theoretical roll centre is a point about which the vehicle rolls, and that's dictated by a measurement between the tyre contact patch and the wishbone pickup points, and so you can adjust where that roll centre is by effectively moving wishbone pickup points, the orientation, the width of the wishbone pickup points. Obviously you can't do that on an original made chassis, but we had a blank page, so we were able to adjust where our roll centre, where we wanted it to be. And what you're trying to do is control that roll centre and the migration of the roll centre. So that roll centre doesn't stay in one position. As the suspension moves, as the car moves, the roll centre migrates. And so what you're trying to do is control that movement. And we found with the Griffith and Chimaera that the roll centre migration actually went off the screen on the software as we were analysing it. And it's the relationship between the centre of gravity. So the centre of gravity is like where the main mass of the weight of the car is, and it's the relationship between the centre of gravity and the height of the roll centre, those 2 points that you're trying to control. The centre of gravity acts like a lever over the roll centre. So as I say, how you do that, once we'd analysed it, how you do that is by changing the orientation of these pickup points. And we found by changing those, we were able to raise the roll centre height, which then gave us better conditions in turn in and roll, and basically you're trying to reduce the amount of roll. Okay, so what the software also allowed us to do was analyse what the cambers were doing. So you generally want some negative camber because it introduces a load into the tyre and generates grip. And you'll find that in certain conditions of turn in and roll, you lose some negative camber, so it's effectively what's known as camber loss. And when we analysed the Griffith and Chimaera, we found that actually the outside wheel on turn in was actually going positive. So you're losing so much grip on that outside front wheel. To combat that is to set more static negative camber into your tune, into your setup. But as everything, that has a compromise on steering feel and straight line stability. So effectively you're trying to reduce that camber loss. So we found that, again, the way we did that was by tuning the roll centre, the wishbone pickup points, the steering axis inclination. By adjusting those, correcting those, we kept analysing different setups until we basically got the tune that we wanted in the suspension. So it brings us back to our upright. So as I said, TVR must have realised as they were developing the Tuscan that the steering axis inclination was excessive on the Griffith and Chimaera, so they developed their own upright. But they went a little bit too far with the steering axis inclination. They reduced it right down to 6 degrees, and we found better results at 7. As I said, we were going to use the Tuscan upright originally in our chassis, but when we analysed it and found better results, we decided to build or have our own upright designed and made. So that's our billet front upright. And then because we were doing a billet alloy front upright, we decided we ought to do the rear as well. So that's TVR's steel fabricated rear upright, which you can probably tell is quite heavy compared to our billet aluminium one. So we went for all tubular CDS, TIG welded wishbones. So TVR used open box section wishbones that we didn't really like. The theory behind it was that they were the weakest point, so if you curbed it or you damaged a wishbone, it would be the wishbone that would fold and it would save your chassis. We didn't like that theory because obviously if your wishbone folds underneath you and you lose control of the car and crash it completely because of that, then that's the worst situation to be in. So we went for fully tubular CDS wishbones. We then decided we didn't like the camber adjustment on the original wishbone, so we developed this in situ adjuster, so we can incrementally adjust the camber on the car with the wheels on. Got away from the sliding joint that TVR used. We then looked at damper heights and mounting and realised there was really no reason why we couldn't have a much more upright, longer damper. Obviously, the longer the damper you can get in there, the more damping effect you've got to control, that you've got to use. And a damper and spring that are inclined creates a falling spring rate, which is fine if that's what you want, because there are certain conditions where you'd want the falling spring rate. So on the rear, you sometimes want the falling spring rate to increase grip as you load up. But when it's kind of, that's all you've got to work with because that's the limitation of the chassis. And there was, as I say, there was no body interference that stopped us creating this much higher position for the rear damper mount. So we were able to get much longer dampers in all four corners. So the next thing we redeveloped was the anti-roll bars. We went for a thicker 25mm front anti-roll bar. Very similar design to the original on the front. It's the only thing that's not fitted to this chassis because we put it on after we fitted the body. Again, tuning your anti-roll bars allows you to run a softer spring setup by having an overall roll stiffness that's controlled not just by your springs but by your anti-roll bars. We also looked at the rear anti-roll bar, and we'll show you a standard Griff one. The standard Griff one operated on the innermost points of the lower wishbone, so isn't that effective, to be honest, and obviously TVR had realised that as they built the Tuscan. So we went for a very similar design to the Tuscan up rear anti-roll bar, which is the full width of the suspension and operates on the furthest most pickup point out from the chassis. We were also driven to change the steering rack, mainly because of availability of parts. The TVR power steering rack's a bit unobtainium, and when you do get them, they always want rebuilding. So we decided we were building these cars from scratch. We were designing a different steering rack. So we found the Subaru Impreza rack to work really well. Very similar shape and design to the TVR rack. Slightly higher ratio, so it's about 2.2 turns lock to lock, and they never break. We've added a fair bit of weight into the chassis by adding lots of tubes and lots more material in. But what we've done is reduce the unsprung weight. So the things that you can't control, that are outside your control of your damper and your spring, is your unsprung weight. And by reducing them, these are the things that you can't control, so they have more of an effect over your handling. So by reducing the weight of those, you're reducing that effect. Okay, we also went away from these. These are the original rubber metallastic bushes that TVR's used and lots of cars used. And we fit these. So these are Powerflex polyurethane bushes. And there's a bit of a misconception about polyurethane bushes, and that they're harsher and difficult to live with, but they're not. I mean, if you can clearly see, there's actually more NVH material on these than there is in the original bush. And what these give you is a completely frictionless movement of the wishbone. They have a DU bush material inside, so they're not just relying on the twist of the bolt inside the bush. They're completely frictionless. So what that means is that the only thing that's controlling your wishbone movement is the damper and the spring. There's no friction in the actual wishbone itself. They're also so easy to fit and forget. They've got a lifetime guarantee. Obviously I should have put some grease in there. But you can actually remove them, rebuild them, take them out. So if you ever had a damaged wishbone, you can actually take these out and reuse them again. So this is one of our Evolution Chassis Griffiths. This is chassis number 2 that we built some years ago. And we're going to take that out for a spin now. All the things that we've just talked about in the workshop, this is the proof in the pudding now. The first thing you notice about driving one is just how precise they are and how easy it is to steer and points where you want it to go, and you're not constantly fighting with the steering to keep it in a straight line and over bumps and cambers in the road. And then if you compared it with a standard car, you'd feel how different the chassis is in terms of stiffness, in terms of torsional stiffness. And again, that's one of the first things we concentrated on, is making the chassis so much stiffer, because all the upgrades and developments you do on suspension don't mean anything if you've got a floppy chassis. So this was the second LS install we ever did. The first one we did was done on a bit of a budget, really, with a second-hand engine, and we had a bit of a feature on it in the Sprint magazine, the TVR Car Club magazine, and Frank, who owns this, spotted it. He had this car from brand new. It spun a big end at 900 miles, so we had to have the engine rebuilt under warranty from TVR, and it never really then had confidence in the Rover V8. It's a bit of a freak occurrence, really, but it never gave him confidence in the original engine. So when he saw we were doing LS installs, and he'd read up about the LS engine anyway, so he came to us and asked us to do a proper install. So we went for a brand new crate motor, and Frank just gave us sort of one directive, really: do it how you want to do it and make it look like it was factory. So I wouldn't say it was open check boot, blank check boot, but it was done how we wanted to do it, and he allowed us then to develop a lot of the parts that we now fit on a regular basis on all our LS installs. So this is a 430 crate motor. GM do a range of horsepower outputs from standard crate motors, the 480 and the 525, but we make this makes 477 and 480 foot-pound of torque, just from better induction, better fuel, better exhaust manifolds. And the 480 engine GM produces, the cam's not as nice as this one, so we're making almost the same amount of power as the 480, but with a nicer cam. It's much nicer, much more tractable at lower revs, and nicer to drive. So this is mated to a TR6060 Tremec 6-speed. It's basically a Chimaera production gearbox. Nice, easy shift, and handles the power. We do fit a bigger T56 Magnum in some of the higher output engines that we fit. This car originally came with a BTR Hydrotrack diff from factory, because it's a Griffith SE, so it's got its original diff, and we do fit the Hydrotrack in when we do our Evolution chassis. Frank bought this brand new Griffith SE. I think he was looking at Tuscans at the time when he walked into a dealership, and this was sitting in the dealers, so he fell in love with it. Some might say it's sacrilege to do what he's done to a Griffith SE, but he's had it from brand new. It's his car, and he's built it how he wanted it, basically, and made it the car that he wanted. So for those of you who don't know, the Griffith SE was sort of a last production run of 100 cars that TVR did, they'd actually stopped production of the Griffith, and they were making Tuscans and Chimaeras, and they must have had quite a few body shells left, so they decided to do a short production run. So they were building these in sort of 2001, 2002. This is a 2002 car, and at the same time they were building the early Tuscans. And they were all numbered. They're all slight variances from an original Griff. So they had the bigger 7-inch headlamps from the Corrado mirrors, and as I was saying earlier, the different tail lamp arrangement. Yeah, so this dashboard is specific to an SE, yeah. So you've got Tuscan air vents, you've got later clocks. Over the years, as I say, we've looked after this car for quite a long time now, and over the years we've also developed the body and paint, and Frank was never happy with the colour, the original colour. It was a bit too browny grey, so he found this colour, which is a BMW colour. It's called dark silver, and this being an SE, it had got the sort of afterthought rear lamp pods that TVR put in with the 4-round lamps, so they did away with the Cavalier tail lamp, which we kind of like because it's just part of the design of the car and the chopped in shape of the tail lamp. But with the SEs, they flushed them in and they put this like I say, a kind of an afterthought pod that filled the hole. Again, Frank never really liked that, so he came up with his own tail light design. He found these tail lights, and so we built pods to mount the tail lamps in, and then re-fiberglassed everything, flushed everything in, and then it had a full repaint. We faired in the front indicators as well using an Audi A4 lower fog light, believe it or not. So, and it's been through various phases. So when it was on its standard chassis, when we first did the LS install, we put a vented bonnet on it because you do struggle with engine bay heat. But because now it's got our Evolution chassis with exhaust manifolds going down the sides, they don't suffer so badly. So he went back to his original bonnet because he preferred the look of it. The beauty of these engines are just so torquey from low down. I mean, you could just poodle around in this in any gear and drive it like an automatic if you wanted to, and then they just unleash. So this second gear, the revs full. So even fourth gear from 2000 revs. It's all about the torque and the displacement. Yeah. There's no replacement for displacement. Obviously, another benefit of this 6-speed gearbox. Now we're doing like 50 mile an hour now, and we're doing 1500 revs. This sits at sort of 85 mile an hour, and it's doing 2000 revs. So for cruising and touring, and they're just fantastic. You know, we're seeing sort of mid 30 mile per gallon on a run. It's just relentless. And you just think, well, I'm going really fast, and then just touch it again, and that torque just comes back again. Telling now poor services and just, you know, country lanes where if you're a normal Griff or Chimaera now, you'd be fighting to keep this in a straight line all the time. It just rides nicely and drives straight and true. So that's where you tuning your roll centers comes in, because you take the roll out of the handling by tuning the roll centers, tune the chassis to start with. Yeah. You don't then have to go really stiff on dampers and spring rates, so it keeps a bit of compliance, keeps a nice ride. It also allows you to put the power down better, because your rear end isn't really stiff. And we did a lot of work on the anti-roll bars as well, so this has got like a Tuscan style rear anti-roll bar, so it's the full width of the car rather than the original rear anti-roll bar that just operated on the inner pickup points on the wishbones that hardly did anything really. So a lot of your roll stiffness is sorted out with the anti-roll bars, which again lets you run softer springs. And obviously it's a road car, it's for road use really. So you want some comfort and some compliance in it. We have our own dampers built as well, so a company called Black Art Designs developed our own dampers for us. And John, the guy that runs that's a bit of a genius. So he's worked at all the major names. And when we first did the first chassis, we took it to him, and he measured all the motion ratios of the wishbones and worked out the right damper rates and spring rates for us. And he even said you've tuned out all the roll, so you need. He went slightly softer to actually put a little bit of roll back in, so that your average driver can feel what the car is doing. So I hope you enjoyed that. Thanks for watching. In researching for this video, I looked back at when we actually built this car and when we developed it. So we originally put the engine in back in 2010 when the car was on 30,000 miles. It's now on 55, so it's done 25,000 miles on this engine. And we were still developing the chassis, so Frank waited for his chassis, which is chassis number 2, and we put that under it in 2014. So it's done roughly 20,000 miles on the chassis, which I think's testament to the durability of the product. So thanks for watching, like and subscribe, and we'll be back with more TVR content soon.